This is 1.4 part 2. We're still on functions, obviously, still in part 2. So we're going to still talking about what functions are and how they work. But more importantly, what we're going to do is we're going to talk about domains. So we've done domains a little bit before in other classes, but we're going to really be focusing on writing domains in interval notation, which I know that we've just gone over that in this class, and interval notation is probably really the most important thing on this because you're going to need it for calculus, you're going to need it for the SAT. It's just important to know how to write things in interval notation. So let's talk about, again, domain and what it means. So domain is the set of all input values x for which the function is defined. And we've talked about this several times before, but basically when we talk about domain and we say all of the input values for which it's defined, it basically is just saying what can we plug in for x. So in this case right here, we're just going to look right at this example. If our function is x plus 2, you want to ask yourself the question is there any restrictions to what I can plug in for x? You know, if I plug in 3, what do I get? I get 5. If I plug in -2, what do I get? I get 0. And you start plugging all these values in, and you start to realize that there is no restriction to what we plug in. And then when you look at the graph is the same way. You see all of these points all over this graph, and you know that this graph continues on forever. So if I plug in a value right here, I have a point. If I plug in another value, I have a point. If I plug in a value over here, I have a point. Even if it's something way over here, eventually that line is going to touch it. There is no restriction. So our domain is all real numbers. So we write that in interval notation just simply as -infinity to +infinity. That is the same thing as saying all real numbers. Okay, let's look at something a little bit different here. This top function, we have the square root of x. So what are the restricted values of square root of x? Well, we can plug in 4, and that gives us 2. We can plug in 9, and that gives us 3. But what happens if we try and plug in like a -4? Well, if we try and plug in -4, the output of that is really 2i. So, but that's not a good value, so we cannot plug in negative values for our square root function. Can we plug in 0? What happens when we plug in 0? Well, the square root of 0 is just 0. So 0 does work. So when we look at our graph, we have a graph that starts at 0 and goes all the way to the right. So there's no restriction how big the x value is, but there is a restriction that it can't be negative. So our domain here, sorry, not a parentheses, because 0 is included, so it'll go from 0 to +infinity. Okay, let's continue on with this. What about a function like this? Well, now it's getting a little bit more complicated because now we have to understand things about different functions. So here we have a fraction, and what do we know about fractions? Hopefully, we understand that our denominator cannot equal 0. That will give us an error, that gives us an invalid output. So in these cases, to figure out our domain, we need to first figure out where our denominator, if our denominator is equal to 0. So we have x squared minus 4 equals 0, and we just solve. We figure out what x values will make this 0. You can factor this if you want to, but I prefer to just add 4 to both sides, and then take the square root of both sides and get plus or minus 2 is what our restriction is. So in this case, x cannot equal plus or minus 2. So is there any other restrictions? Well, there's no restrictions of what we can plug in on the top. We can substitute any value we want into the top, as long as it doesn't make the bottom 0. So the only restrictions here are plus or minus 2. So how do we write this as an interval? Well, real simple. We're going to start at -infinity. We know that anything from -infinity all the way to -2 will work. Notice the -2 is not included. And then what we do is we put this little symbol. This means union. This means this or this, okay? So then we look at our graph. So we went from -infinity all the way to -2. There's this little thing called an asymptote at -2 because it can never equal that. Well, then we have this little space in between -2 and +2 because that is also valid. So in between -2 and +2 is also part of our domain, union, and then from 2 to infinity. And that's from this point all the way over here. So you notice there's all parentheses here. So basically we're saying from -infinity to -2, not including it. from negative 2 to 2, not including either of those, and then from 2 to infinity, not including it. So once again, that's how we represent all real numbers except for positive or negative 2. We've talked about domain in this way before, but now we're just talking about it in interval notation with maybe some more complex functions. Okay, so that's how you do that one in interval notation. Let's move on to the next one. So the next one, I think, is a little bit easier. We have a square root function here, t minus 5. So how does this work? Well, what we want to do is we want to first establish that t minus 5 it has to be positive. It has to be 0 or positive. It cannot be less than 0. So we say t minus 5 is greater than or equal to 0. That is what our domain has to be. And then we just solve that. Add 5 to both sides, and we have t is greater than 5. So how do we represent that in interval notation? Real simple. It can be equal to, so it's bracket 5 all the way to infinity. That's how you represent this in bracket notation. But this is what the domain is, this is what the domain is. They mean the same thing. But we just want to get comfortable writing it in bracket notation. Now, you can't always use an inequality to solve, and we're going to see that right here. When we are dealing with squares underneath a square root, we're not going to use an inequality to solve this. Instead, we're going to use some common sense. So there's two things that have to be true here. We have to be greater than 0. Our square root has to be greater than 0, greater than or equal to 0. Also, we're on the bottom. So because we're on the bottom of a fraction, it cannot be equal to 0. So what we can just do is we can say that this bottom has to be greater than 0. Underneath the square root has to be greater than 0. X squared minus 9 is greater than 0 because it can't be equal to 0 in this case. Now, we are not going to solve this as an inequality. We will get really messed up if we try that. Instead, what we're going to do is use a little bit of common sense. We're going to say x squared minus 9 equals 0 to figure out where our cutoff points are. X squared equals 9. X is equal to plus or minus 3. So we first of all know that x cannot be equal to positive 3 or negative 3. But we also need to think about what values will then work. Can the values that are greater than 3 work? If I put in 4 squared is 16, 16 minus 9, is that positive? Yes. So we know that x can be greater than 3. What about for the negative 3? We don't want to say x can be greater than negative 3 because what happens when I put in negative 2? Negative 2 squared is 4. 4 minus 9 is negative 5, and we get a negative. But what about values that are less than negative 3? And again, we can look at the graph and kind of see that. So the values that are less than negative 3, negative 4. Negative 4 squared is 16. 16 minus 9 is positive. So then we can say that x is less than negative 3. So what does that mean? This is what we've just defined as our domain. We know that it can't be equal to 3 because that would make a 0 on the bottom. And we also know that it has to be greater than 3 and it has to be less than negative 3. So when we write out interval notation, we have negative infinity to negative 3 union, and it can, now in this case, we don't have anything in between them. And the reason why we don't have anything in between them is because it can't be, anything in between them would give us a negative underneath that square root. So now we just jump to positive 3, and that will go to positive infinity. So anything from negative infinity to negative 3 will keep this positive and not make it 0. And anything from 3 to infinity will make this positive and not make it 0. So there's our domain. So this one's a little bit trickier for sure because you're dealing with two different things. Can't be 0 and can't be negative. But we can use a little bit of common sense and our graph to kind of figure out what those values are going to have to be. Okay, we have one more that we want to do. Okay, so we have 5x minus 2 over x squared plus 7x plus 12. Again, top doesn't really matter much here. The only thing that matters is the bottom. The bottom cannot equal 0. So what we do is we just simply solve. We factor it and figure out what values would make it 0. So we factor this, and this becomes x plus 3 and x plus 4. So x is equal to negative 3. X is equal to negative 4. Those are the values that it cannot be. So therefore, we write out our interval notation from negative infinity to negative 4. from -4 to -3, and from -3 to positive infinity. This shows that every real number will work except for -4 and -3, because we have parentheses for all of those, which means they are not included. So that everything works except for those exact points. Real easy to write a domain for these ones once you understand the concept of setting the bottom equal to 0 and figuring out what the factors are and knowing what values will not work. Okay, for this last one, let's see. I want to see if you guys can do this one on your own. See if you can come to class and do this on your own. Remind me when you get to class that we need to do this, that this is one thing we need to go over, and we'll see how you do. So hopefully this makes sense. I know it's a little bit tricky, and we will obviously, that's why it was a separate video for this part. I didn't think we could cram this all into one with all the other stuff from 1.4. So, just make sure if you have questions, bring them to class, and I will see you then.